and we'll do some questions based on the relative velocity. Okay. Also, we have done velocity components. Let us first study about the relative velocity. Okay. So relative velocity, it means the velocity of an object or the velocity of a body with respect to another body, with respect to another body in motion. Another body is okay. So this is what we call as the relative velocity. So relative velocity simply means, see, suppose here we have a highway, and on the highway we have two cars which are moving. Okay. So this is the first stage I am drawing. You have two cars which have some distance of separation between them. Let us say they have a distance of separation as 1 kilometer in between them. Suppose now I am an observer, stationary observer who is standing over here on the ground. So I'm standing here on the ground and I'm observing these two cars. So I observe that this car is moving with some speed, let's say 60 kilometer per hour. And let's say this car is also moving in the same direction with some speed of 90 kilometer per hour. Now, this is what I am observing. I am observing this car to be moving with 90 kilometer per hour. I am observing this car to be moving with 60 kilometer per hour. Okay. Now, what will a passenger sitting in this car A? This is your car A. And what will this passenger observe? A passenger sitting in the car A, how will he observe this car? What speed will he observe for this car? And what speed will he observe for me? If he observes me, so how will he observe me? What speed will he observe me?
60 kilometers. Big
Okay.
backside.
Yeah. So for the stationary observer, to me, this car A will observe me to be going in the backward direction with a speed of 60 kilometer per hour. So velocity of the stationary observer will be minus 60 kilometer per hour. But this is with respect to the observer A. So we write it like this. Velocity with respect to A of the observer is minus 60 kilometer per hour. And what will be my velocity with respect to the observer with respect to B?
Mm-hmm. 90.
Yes, how much?
So with B to respect to
Yeah, I want velocity of the observer with respect to B. So what velocity will the B observe me?
90.
90 in the opposite direction.
Yes, sir. Minus 90.
So yeah, so we have minus 90 kilometer per hour. So this is what we call as the relative velocity. Relative velocity means the velocity of an object with respect to someone. So the same object, I'm standing on the ground. So if I ask some observer on the ground, I'm asking someone who is there on the ground. So that person will say that you are stationary and will find my velocity to be 0 kilometer per hour. Okay. If I'm to an observer who is moving in the car, it seems that I have a velocity of minus 60 kilometer per hour. To an observer in car B, it seems that my velocity is minus 90 kilometer per hour. Okay. In the similar way, if I say what will be the velocity of B with respect to A, I want to find velocity of B with respect to A. Yes, any answer?
So could you repeat?
Okay, so the what will be the velocity of B with respect to A? A is moving like this with 60 kilometer per hour. B is moving like this with 90 kilometer per hour. So it will assume that
30,
B will, yes,
30, 30 kilometers per.
yeah, it will observe to A that B is moving with a speed of 30 kilometer per hour towards the right side. Okay. So it will seem to A that B is coming towards A with a speed of 30 kilometer per hour. Okay. What if both the vehicles have the same speed? Then this I have written here. This is your velocity of B with respect to A. This is we have velocity of observer with respect to A. This is velocity of B with respect to O. Velocity of O with respect to B. So this is okay. What does this relative velocity mean? That the distance between them. Suppose and how do I find out the relative velocity? The basic idea to find out the relative velocity. Suppose here I was finding out the velocity of B with respect to A. So I have to find the velocity with respect to A. That means I must make this stationary. I assume A to be stationary, and to have A to be stationary, I will find I will subtract the velocity VA from the velocity VA, and hence I will get the velocity 0 meter per second. So I assume the velocity of A or A object to be stationary. And when I assume A to be stationary, so I have to subtract velocity VA from the velocity VA, that makes it 0 meter per second. Now, since I have subtracted from A, so to balance it, I must also, since both of them, they are in the same frame of reference. So I must subtract the velocity VA from the velocity B. So I should write velocity of B minus the velocity of A. Okay. So this will give me VB minus VA will give the relative velocity. This is what we call as relative velocity of B with respect to A. Okay. So if you are asked the relative velocity of a substance with respect to another, you can apply the definition like this. Subtract the velocity of the object of which you are which is with respect to which you are observing. Have you got this? Understood? This one? Understood this?
Yes, sir.
Okay. So if I give you one, so what the benefit is that suppose I want to find out that how much time will it take for B to reach A. See, the situation is something dynamic. As B approaches towards A shifts ahead. Okay. So in the beginning, I observed them that they had a distance of 1 kilometer in between. Now, can you tell that how much time will it take for B to overtake A or to reach A? I have two questions. Let's see first you try out, and then I will tell how to solve it out. So first you have
Good evening, sir.
yeah, good evening. Okay, so why people don't join on time? Please join, keep joining on time. Okay, if you join on time, otherwise see, you now have only 15 minutes left.
Yes, sir. Actually, I had some.
Okay. See, uh, you have the question here, cars A and B. Cars A and B travel with a speed of 60 km per hour and 90 km per hour. So cars A and B travel with a speed of 60 km per hour and 90 km per hour in the same direction. In the same direction with A ahead of B. A ahead of B. If B is 1 kilometer, 1 kilometer behind A, find the time taken by A or time taken by B to overtake A. So let's try to find out. I hope you can do this. So try out your methods, how you go doing this. Okay, so okay. Okay, Shashi, sure, I'll be revising it. So just try to do it if by any means you are able to solve this question. Cars A and B travel with speed of 60 km and 90 km per hour in the same direction with A ahead of B. If B is 1 kilometer behind A, find the time taken by B to overtake A. So there is one method that you can use like this.
So for the car, it's like 1 minute per second, 1 minute per minute, and 1 kilometer per minute, and car B it's 1.5
Okay,
kilometer.
let's see. There are these two ways that I can try out. See, I have this car B which is behind. So this is car B which is behind. This is car A which is ahead. It's moving with so velocity of A I write as 60 km per hour. Velocity of B I write as 90 km per hour. So and they are just 1 kilometer apart. They are 1 kilometer apart from each other. So I want you that how much time will it take for B to overtake A? So let us say they both meet each other at this point. So suppose B is able to overtake A at this point. Okay. So let us say after some time T, B is able to overtake A, and during this time, A travels a certain distance X. So what will be the distance traveled by B? If A has traveled a distance of X kilometer, so what will be the distance traveled by B? Okay, X plus 1. Very good. Distance traveled by B will be X plus 1, and the time taken by both of them will remain the same. The time taken by both of them will remain the same since time is universal. So both of them, A also travels for the time t, B also travels for the time t. Now I can use the speed of A. So using the speed of A, I can get the value of, I can get here speed, that is 60 kilometer per hour, equals to distance by time, which is x by t. So I can get the value of t as 60 by x. Okay. Now in the same way, I can obtain the value of time from the other expression. So here I get 90 is equal to x plus 1, which is distance is x plus 1 and time is t. So again, I can get the value of time t as x plus 1 by 90. Okay, x over 60, sorry, it's x over 60, my mistake. Thank you. So this is x over 60, not 60 by x. So now I can get that both of them are equal. See, both of them are equal. Since the time is same for both of them, I can equate both of them and I will get here x by 60 equals to x plus 1 by 90. And now you can cancel from both sides. You can get here 30, 2 times 60 and 3 times 90. Cross multiply, you get 3x equals 2x plus 2. And hence you get x equals to 2. Okay. So that means A will travel a distance of 2 kilometer. Okay. So knowing the value of A, I can get the value of time. Knowing the value of x, I can get the value of time. So t will be equal to 2 by 60, which is 1 by 30. So this is 1 by 30 hours. And I can convert this 1 by 30 hour to minute. So 1 by 30 multiplied minute. So multiply 60. It will take 2 minutes. Okay. So your answer is B will be able to overtake A in 2 minutes. Got it? Understood this? I think everyone has understood.
Yes, sir.
Okay. So now see my method. This is how we are going originally. Now what I see, why not assume A to be stationary? Okay. I assume here A to be stationary. You need to understand this method also. So if I'm making this complete system, I'm making A to be stationary. So I will be subtracting the velocity VA from here. So here I'm making A stationary and hence I'm finding out the relative velocity of B. I'm finding out here relative velocity of B with respect to A. Okay. So relative velocity of B with respect to A will be VB minus VA. The velocity of B is 90 and the velocity of A is 60. If you subtract, so you get here 30 kilometer per hour. So now it means that the whole system is stationary, that A is stationary and B is traveling with the speed of 30 kilometer per hour towards A, and it has to travel a distance of 1 kilometer. So now I will use, I know my speed is given as 30 kilometer per hour and time is given to us as time we have to find out, and distance between them is 1 kilometer. So that is the distance that is to be traveled. So I can get my time to be distance by speed. Distance is 1, speed is 30, 1 by 30. Convert 1 by 30 to minute, multiplied by 60. You get your answer 2 minutes. Got it? Yes? Okay.
Yes, sir.
See, so this here I have used the concept of the relative velocity. So we need to understand that relative velocity means the velocity of an object or velocity of a body with respect to another body. So the velocity of a body with respect to another body, we call it as the relative velocity. Now, okay, I give you one more question here. Let's try to solve that out. Maybe you are able to use the idea of let's say if you are able to use the idea of relative velocity or not. So first of all, I'm giving you a simple ones. Okay, and then I'll give you a little bit complex. So here you have a police van is running behind a thief van. Okay, so the thief van is moving with a speed of with a constant speed of 90 kilometer per hour, and the police van is running with a speed of 120 kilometer per hour. So find the time taken by the police van to catch the thief if the distance between them is 1.5 kilometer. Okay. Also find the distance traveled by police van. Okay, try solving it out if you are able to get the answer by any of the means. Hmm. Yes, so I think has someone got any answer? Okay, Dhanunjay has given the answer. Mhm. See, you can use the concept of the relative velocity. If I directly use the concept of the relative velocity, I get the relative velocity of police with respect to thief to be 120 minus 90, which will be 30 kilometer per hour. And with the speed of 30 kilometer per hour, the police van has to travel a distance of 1.5 kilometers. Okay. So the police one has to travel a distance of 1.5 kilometer. I know my distance to be 1.5 kilometer, and hence time will be equal to distance by speed. Your distance is 1.5 divided by 30, which is 15 by 300. So 1 by 20, complete it into minutes. So you get your answer as 3 minutes. The police will be able to catch the thief within 3 minutes. Okay. Then the distance traveled by the police. Okay, Dhanunjay, answer is 3 minutes, not 3 seconds. You got your answer correct. Okay, but since we are getting in kilometer per hour, so the answer will be in hour. Multiply by 60, you get in minute. So we get here 3 minutes.
Okay, sir.
Now, if I say what will be the distance traveled by the police, so police vehicle is moving at a speed of 120 kilometer per hour and it is traveling for 3 minutes. So that's 1 by 20 hour. You can find out the distance traveled by police vehicle. Distance will be given by speed multiplied time. So speed is 120 multiplied by time, which is 1 by 20. So you can cancel this 2 and you have 6. So police vehicle will be traveling a total distance of 6 kilometers to catch up the thief. Okay. So I'm making this question a little bit complex. Let us see, and if you can do it as a part of your homework. So just adding a little bit more information to the question. Okay. Find the minimum acceleration required by the police van. Find the minimum acceleration required by the police van if it wants to catch the thief within 4 kilometers of its run. So let's see if you are able to do this or not as a part of your homework. Okay. So what should be the minimum acceleration required by the police van if it wants to catch the thief within 4 kilometers of its run? Okay. So bye all of you. See you again in the next class. If you have this question, good. If you do not have, you can take the screenshot of the question.
Bye, sir. Have a nice day.